Howdy, this is a production by Dana, Ashley, Rachel, and Julie about DNA replication.
What is DNA? DNA is known as deoxyribonucleic acid and is the fundamental hereditary material for all living organisms. It is found in the nucleus. DNA is helical shaped and looks like a twisted ladder. There are two strands that make up DNA, and they are anti-parallel. They run in opposite directions. One goes from 3 to 5, while the other one runs 5 to 3. DNA consists of a phosphate, pentose sugar, and nitrogen bases. There are 4 different nitrogen bases. Adenosine pairs with thymidine, guanosine pairs with cytidine.
I wish I was adenosine, then I could get paired with you.
No, that's only an RNA, and ew.
In order for organisms to grow and develop, DNA must multiply.
You mean divide.
Actually, both of you are right. Biology is the only science where multiply and divide mean the same thing.
DNA is replicated completely and accurately during cell division. Semi-conservative replication is the process in which each strand of the parental DNA acts as a template for the new strand. It occurs in 2 steps.
During the first step, DNA is unwound. It begins at the origin of replication, which is where the helicase and the pre-replication complex binds. Helicase unzips the parent DNA strands.
Hey baby, I wish I were helicase so I could unzip your genes.
Seriously? Now that the DNA is unwound, replication can start in both directions, forming one replication fork. The replication fork is the point in which DNA is replicating.
The DNA has been split, so we now move to the next step. An enzyme called primase starts to bind a template strand. The primase forms a starter strand called the RNA primer. Once primase is finished synthesizing the primer, it is released and DNA polymerase III binds and continues the replication process. Hey guys, I have another joke.
Julie, don't make me polymerasing from existence.
Wow, way to steal my thunder.
At the replication fork, the DNA opens up in one direction. The fork creates a leading and lagging strand. Let's first look at the leading strand. The leading strand continuously grows from its 5 to 3 ends as the fork opens. As you can see, the leading strand is pretty straightforward. And it is continuous because it continuously grows and replicates as the replication fork opens.
The other new strand, the lagging strand, must be synthesized differently because it grows in the direction away from the replication fork. Synthesis of the lagging strand requires the synthesis of relatively short and discontinuous stretches of sequence. These stretches of new DNA are called Ozaki fragments. Each fragment requires its own primer to be synthesized by the primase. And then, DNA polymerase then synthesizes an Ozaki fragment by adding nucleotides to one primer until it reaches the primer of the previous fragment. The enzyme DNA ligase catalyzes the formation of that bond, linking the fragments and making the lagging strand whole again.
Oh, how the nucleotides have turned.
Ugh.
DNA's first step was to split the 2 parent strands, and now they're being rebonded together.
Can you stop with the terrible jokes and puns?
I know I make horrible science puns, but only periodically. After the leading and lagging strands are replicated, you are left with 2 strands that make up the parent and daughter DNA strands.